What up, chemistry students? Let's get this party started. I uploaded your chemistry exam. Guess what? It's going to be more of a project as opposed to a regular straight-up test. I'm really just trying to, I don't know, I know a lot of you folks in algebra or chemistry are also in my algebra class. I'm really trying to do this so that it's, well, first of all, I have two reasons for doing this. My first reason is because they told me to make your final exams more project-based than an actual test for this quarter. So I said, okay. But really, and I think that it's actually a good thing, because what it's doing is it's kind of like taking a little bit of the pressure off of you. So here's what your exam is going to be all about. Let me see if I can find it. I uploaded it, and it's all up into your classroom already. Let's go to chemistry, check it out. So for all of my classes, all I have are these project-based final exams. That's my style for quarter one. I think this one's a really cool one. All right. What I want you to do is I want you to make a copy. Uh-oh. Well, I guess you couldn't do the final exam because I didn't upload it correctly. Let me make sure that this all works out. Give me a second. What is Kim saying? Sorry, one second. Kim. Oh. That's what it was. Okay. So I made I made 5 different periodic tables from this thing that we have as the periodic trends that we made, right? And I was going to have a whole lesson where we analyze all of the different intricacies of these beautiful models that you've built. I say beautiful because I've never seen anything of this quality. I'm really excited about this kind of project that we did. I didn't have time to cover that lesson on the different, trends that you would see in the periodic table. That you guys spent hours and hours and hours. Literally, some of you spent like 3 hours on this thing. I'm sure of it, right? So you guys worked so hard on this thing, and now we don't have the time to I didn't have the time to really go into and discuss the intricacies of this thing. So what I decided to do was make this your final exam. Your final exam is basically you discuss the intricacies of this thing. And you go and do the research on why these trends look the way they do. And give me a presentation on it. And you basically become the teacher. It's a flipped classroom. You are the teacher, and I'm the student, and I'm receiving the lesson that you guys are going to be giving me. Cool? So, what you're going to need to do is you're going to need to record a screen capture of you going through all of these different periodic tables and talking about the different parts of them. Like, for example, this is the electron affinity. This is how, I suppose that there's a complicated answer to what is electron affinity, and that's something you will want to discuss in it. I suppose that my answer to that would be how eager an atom is willing to give away an electron or receive an electron, or basically change the amount of electrons it has, right? And look at this periodic table. The electron affinity has almost, all the noble gases are almost at 0. Why is that? Why are they not willing or eager to give up any electrons? Because their shells are very full. They're very content. They're happy. Happy shells, right? Whereas fluorine, chlorine, bromine, iodine, and AT is what? Antimony? No, that's what was AT again? No. Celeste, do you know what AT is? No, SB is antimony. AT? No, it's not acetone. Acetone is a chemical compound. Acetate? No. It's something, I forgot what it was. But those guys in the column right before the noble gases, why are those so high? Because they're that close to being perfect, so they desperately want something to happen. And what is it specifically that they want to happen? They want to gain an extra electron. So that's why those guys are so high up there. So do you see this discussion I'm having with you? Just by looking at this, the trends of this thing and where the spikes are and how this thing kind of looks like a little, this thing kind of looks like a skateboard ramp where it's high on this side and it's high on this side and it's low in the middle. That's what I want you guys to go through about in your final exam. Your final exam is basically going to be go through all of these things and answer these kinds of questions. And I have questions that I wrote up for them. So this doesn't mean I want you to just answer the questions, blah, 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 blah. I want you to become a teacher, make a lesson, come up exactly with some pictures that you want to show that explains to me what electron affinity is. And what you'll probably want to do is go into talking about the valence electrons and the shells and all of those kinds of things, right? So you'll need to go onto Google and find some pictures of shells of atoms and what a valence electron is and explain that to your quote-unquote students. Does that make sense? And then basically I just came up with a whole bunch of questions that you can answer. But not answer, I don't just ask the question and I want you to answer them. I want you to discuss these things with me. Remember, you're the teacher. You need to explain all of these things, from your perspective. Here's the best way I found to screen record on your computer. Your Chromebooks, do they have, on the top right-hand side, there might be a button that looks like a film roll. And if you don't know what a film roll is, look it up. Because you probably don't know what a film roll looks like. Does it say like Screencastify? Okay. If you click on that, that's a good program to use to record your screen. I think the only complications that I had with it was you can only record the screen, you can only record the tab that you started the Screencastify from. So I don't think it does a full on-screen recording, but you can only record the tab that you started it from. Which might be a problem if you want to switch back and forth between like a presentation and this 3D model. You know what I mean? So, another option that I know Chromebooks can do, but I haven't gone through all the steps of figuring it out, is you can create a Google Hangout session with maybe yourself or a friend or something like that. And then you can even explain it to that friend, and you can actually do a screen share, and it will record your screen. That's another option that you guys can look into. I can try to figure out the intricacies of that if you guys want later on. But that's your final exam. Could we make a PowerPoint with a voice recording? Yes, you can absolutely make a PowerPoint with a voice recording. I'm totally fine with that. What you might want to do in the PowerPoint is you might want to navigate around this thing, this periodic table in the 3D version. And what you might need to do is take a bunch of snapshots on your computer, so you have all those slides on your PowerPoint or whatever. So I'm absolutely fine with that. I think there's also another thing that's called, I'm not sure if Jing works on the Chromebooks. I think that it might. And there's another one. Gosh, Sarah, do you remember that one we used to use like 3 years ago where we uploaded all the slides and we did a voice thing? VoiceThread, that's what it was.
But I don't think Jane works on the Chromebooks. I just had my bio student do the assignment, and some of them were able to use Screencastify, and some of them had trouble. So you should probably take a look at it now. Don't wait until the last minute.
Oh, yeah.
Look at those programs now to make sure that you can familiarize yourself with it and do any troubleshooting.
So what Sarah is saying, because those of you online couldn't hear, is what Sarah was saying is that some students were able to use Screencastify, some students weren't. What we were saying is, I'm giving you a week to do this final exam, and don't start it today. Don't wait till the last minute to just do all of your recording and that kind of stuff. If not, I guarantee you it's not going to work for you, and you're just going to be all frustrated and be freaking out and all that kind of stuff. The whole point of me doing a final exam like this is to give you folks time to really give me something good, to give me a good product. Got it? So that's why I'm doing the math the way I'm doing it. I'm doing the chemistry the way I'm doing it. It's tougher for me because I got to make my final exam ahead of time, but it's better for you because you have more time on it. And I guess my last thing that I want to tell you is, I do obviously want you to spend a lot of time on this, but don't spend all of your time on this. You have other classes, other final exams. Make sure you do well in those things too. Obviously, I want you to pass chemistry, and obviously chemistry is maybe even the hardest class you're taking, but don't kill yourself over it. Got it? I mean, do you know what I mean? Like, I could imagine if I give a project like this, some students who are really like crazy, and not crazy in a good way, tend to just like put all of their energy into it, and they end up making like this amazing, beautiful website or something, you know, for this thing, way above and beyond. Obviously, they'll get an A or whatever, but then they suck up all of their time and they don't do their math tests, or they don't do their English paper that they have to do. Maybe because this is a more fun project or something like that. You know what I mean? Don't kill yourself over this project, all right? Don't go crazy. Just answer the questions that I have, do the challenge questions, make it pretty, make it nice, and work on your other final exams. Cool? I'm giving it to you way ahead of time because ideally you can finish this now and then not worry about your chemistry exam next week. And if you have algebra and chemistry from me, then not worry about those two exams next week at all. Just like, I'm done. I finished a week early. You know what I mean? And then that way you can only concentrate on one thing. And that must be much prettier for you, much nicer. You'll be in a much happier state. So don't push this off. Now, let me answer some questions. Bradley, you needed help on yesterday's homework. Yes, of course I'll help you. That's kind of what chemistry has become. This homework has been so hard that I've been kind of basically tutoring you guys through most of the class. Of course, let's get to it. For today's work, try using Desmos. It helped me a lot. Are you talking about math or are you talking about chemistry? Wait, are you guys talking about yesterday's homework for math or chemistry? Sorry. Oh, Desmos helps? That's cool. I didn't realize it. Actually, I had something I wanted to cover today. I think you guys are getting confused. All right, does anyone have any questions about the final exam? Let me ask you this. Does anyone have any problems with how I'm doing the final exam? Would you guys rather me do, you know, like 20 stoichiometry problems or something like that? Is that?
Are we doing a lab today?
Today's lab is going to be more of a, yeah. All right. Today's lab is not really, we're not going to be using chemicals or pouring anything. I need to finish off talking about stoichiometry. And this is actually my last lecture that I have with you guys before we finish off this quarter, and I need to finish off chapter 3. So I apologize. I didn't come up with this really cool creative lab. It's just kind of straight up tutoring and teaching. Okay? But I'll try to make it exciting. All right. So I'm going to ask one more time. Any questions about final exam?
What is the final exam? What's that part?
That's all we've just been talking about.
Does it have to do?
I'll give you the quick rundown.
Yeah.
Here's what it is. See this thing?
Yeah.
You guys made it. I just stole it from you. There's 5 of them. This one has to do with electron affinity. This one has to do with electronegativity. Here's an awesome graph that I really like. It's the density one. This one is atomic radius. And I think a classic one is the ionization energy. There isn't a whole lot of resources out there that explain why the trends look the way they do. But I think they're very interesting. I think they're very important to understand why you've made a 3-dimensional periodic table. And the reason why there's not a whole lot of things is because I think it would be too much of a pain to build the models like this. But since we have a 3D printer, theoretically we could build models like this. I don't know why teachers haven't given this as an assignment before. I think it's awesome. I mean, not to say that I think I make awesome assignments, but I think it's a really awesome project that we can do. So what we can do, and you work so hard on it. We didn't have time to explain all of the different parts of this periodic trends. So your final exam is basically you giving a lesson, explaining the different parts. You have to go and do research, figure out why it looks the way it looks. Then, from that, you can give me a little lesson, mini lesson. Is there a time limit? I would say there's no way you could finish explaining it to me under 5 minutes, so probably longer than 5 minutes. Don't be giving me an hour-long lesson. I won't watch the whole thing. I mean, I'll watch your lesson because you guys spent the time making it, but I mean, I don't want to be sitting there watching, what is it, how many students I got? Like 40, so 40 hours worth of chemistry finals to watch and grade? No, thank you. Just kind of keep it maybe around 15, 20 minutes if you can. Yeah, that is a lot of time. Actually, I regret saying it as soon as it came out of my mouth. Longer than 5 minutes, way under 15. Sound fair? So around 10, on average. I would say that that's enough time for you to get across all of your points. And you know what? You don't need to, try to cover all of the things that I said. I even added some challenge questions in there. I haven't decided on what the points look like. Obviously, students who go above and beyond will get more points and that kind of stuff. I'm still trying to figure that out. I just was able to kick out this exam for you as quick as possible. All right. No other questions? All right. Bradley's asking lots of questions about chemistry.
Yes, Jack.
That's right. Thank you. I'll be here all night. Okay. Just 2. Okay. You know what? Can I finish my lesson on balancing equations real quick? And then we can do, I can open it up for straight tutoring and that kind of stuff. My plan was, all right, so let's start our lesson. Got to go at 3. I'll try to finish as quickly as I can. I've just been going as best as I can. Watch the archive, I would say. All right, fine. Bradley and Genesis, why don't you ask me your questions since you have to leave? We're going to switch it up. I'm going to do some tutoring, and then we'll go into the lesson that I had prepared in my head. What's your questions? What was that? Was that your ringtone or something? Was that your ringtone?
No, that was fine.
Oh, you like listening to
Big Crosby, yeah.
Bing Crosby? That's pretty cool. All right, last problem from yesterday. Oh, by the way, this final exam is worth 100 points. That's the way finals exams are work. So take it seriously. Do a good job. All right. What is a problem from yesterday that we did? What was yesterday's homework? Was it molar mass 2? Or was it percent composition? All right. Percent composition. Let's see what that homework is. The last two? Did you guys have trouble with this? I didn't even do it yet. Was it hard? All right, let's see. What is the percent by mass of nitrogen for a compound is found to be blah, blah, blah? Which of the following could be this species? Ooh, that's a tricky one. All right, let's do it. Let me go over to my camera, get that to work. Allow. Give me a second. My computer is loading up the camera. Give me a second. How do you answer the question though? Let's see. How are you supposed to input your answer? Oh, it's a multiple choice. Oh, and apparently it's NO. So we know the answer already. I was wondering how am I asking you to input the thing? All right. What's wrong with the camera? Come on. Allow. Yes, I want to allow. Arg. All right. I'm having some trouble with this. I'm gonna have to log out and log back in. Okay. Microphone. Yes, share. Allow the camera. All right, camera. Allow. Allow. What? It was working with algebra. Frozen. And not the movie, but the bad way. Let's see. Let's go with this. Duplicate. Sorry, technical difficulties. Conferences. Whew. I tell you, man. Wednesdays are crazy. I feel like all I've been doing is just running around. But like I said, I like hanging out with you guys. Ooh, oops, I need to change that. Not a whole lot of students in class, huh? Audio check. Can you guys hear me? All right, the camera works on this computer. I had to switch. The problem is screen share doesn't work with Chrome, and apparently the camera doesn't work with, and so I had to use Firefox to share my computer screen. But then Firefox wasn't letting me share my computer or my camera, so I'm sharing with you now. Can you guys see my face? All right, cool. So the problem was, which one of these has 46% nitrogen composition? Is that what it said? Let's see. 46 point. Wait, which one is it? Which problem did you want? Number 77? Oh, just the last one. Okay, fine. Last one. All right. Fungal lacus is a blue protein found in wood-rotting fungi. Is 0.39% copper by mass. If fungal lacus molecule contains 4 copper atoms, what is the molar mass of fungal lacus? Okay, all right. 4 copper atoms. All right, here we go. So, copper. What's the molar mass of copper? The equation for fungal Lucas, I have no idea what it is. Let's just say it's FuCu. Actually, that's probably, let's not do that.
UCUKU.
Yeah, no, let's not go with that. It will be, I was saying Fu as in like fungal and then Cu as in copper. Yeah. Let's call it FCU. That's off just enough for me not to really be worried. All right, and apparently it's F. I don't want to use F though. I don't want to use FL. Well, let's just use F.
Use FL. Fungal Lucas.
Well, the problem is that looks like, all right, FL. That looks like fluorine to me. But fluorine is F all by itself. So yeah. This is just a made up whatever. I don't know what the rest of it is, but I know that Cu, and I know it's got Cu4 in it, right? All right. What is copper? If we look at copper, the molar mass of it is what? 63. 0.546 grams for every mole of this stuff. And how much percent is it? Huh? No, it was, didn't it give me a percentage of it?
Yeah.
Oh, 39%? Oh, 0.39%.
Yeah.
Oh, it was made of 0.39% of that stuff. Just 390, was it 3905 or something?
No, just 390 because the 0 gets.
Okay. All right. So convert that into a regular number, and that's 0.0039. Right? Because it goes from percentage to regular number. Okay. So, I think, what is the best way to solve this problem? This one's a little bit tough. If this makes up 39, let's see. If copper makes 10% of this thing, let's deal with easier numbers. Let's say copper makes up 50% of this thing. Yeah. Let's change this to a 50%. I'm just trying to be honest with you, I'm looking at this, I'm like, man, I don't even know how to solve this problem off the top of my head. It's been a while. So I'm just going to spitball it and show you kind of how my brain will think about this problem. Fair enough? All right. Let's say that there are, okay, here's how I would do it. There's 4 copper molecules in every bunch of this, right? So I'm going to multiply this by 4. Someone do that on their calculator for me. I'm going to multiply this number by 4. Use a calculator. I hope I get the right answer. What did you get?
254.
254.84.
184.
184 grams of copper for every mole of FLCl or FLCu. Got it? By the way, FLCu is not an actual chemical compound. I just don't know what the chemical compound is for that thing. So, I just call it something like that. I just know that it has Cu4, so I did that. Now, let's say this was 50%, not 0.39%. That's a little weird percentage. But copper made up half of this thing. Then, what would the mass of the entire thing be? Do you guys know? You multiply it by 2. Which is about 500, right? Because if it were about 500 grams worth of this stuff, and half of it was copper, and copper made up, had 4 molecules of copper in it, then you would multiply by 2. Or maybe, since to relate it back to my 50%, I would divide it by 0.5. Dividing by half is the same as multiplying by 2. Does that make sense? So I feel like this... Wait, what are they saying? I can't even read that. Sorry. Okay. All right. All right. What is FuCu2? No, this is FlCu4. And it's just, I don't know, I just made it up because I don't know what the compound formula, the chemical compound formula is.
Yeah.
Oh.
Yeah. Yeah.
Yeah, that was a funny joke. Okay, all right. So now I know what to do with the percentage, right? You divide it. So, since I made the numbers easier, it kind of showed me, okay, this makes it kind of obvious. Is it obvious to you?
Yeah.
If this were 50%, then what I would do is I would divide it by 0.5, which is also what 50% represents, and then that would give me my answer. So I'm betting that the right answer is this number divided by 0.0039, which I'm betting is a really big number. Tell me what that answer is. Huh?
65175.3846.
665 what?
175.
175.
0.3846.
0.3846.
Yeah.
I started off with 3 sig figs, so I'm going to round that off to 65200. Is that all right with you? Well, I had to round it off because I started off with 3 sig figs to begin with. So I need to have 3 sig figs in the end. 65200. I told the computer to give you a correct answer if you put in... Oh,
Yeah.
I got 654. But it gave you a margin of 1,000, so 652 is within that. I guess I should change that to a 2. Yeah, I fixed it. But the margin of 1,000 should have taken care of that, so yeah. I'm very generous with this margin of error. If you got anywhere in that ballpark, I'd be happy. Fair enough? Bradley, we cool? Are we still friends? Alright. Oh, it's 65200. Sorry, the glare. Let's see. I don't know how to get rid of that glare. I'll show you how to get rid of the glare. 65200. The glare's still there. I'm a poet. Like a boss. QED. Alright, we cool? Can I go and teach you guys the lesson that I was planning on teaching? Alright. I'll be honest with you, I didn't know how to do that problem like right off the bat, off the top of my head. So what I do, and this is how I approach problems, this is how I approach math, is I'll do problems, I'll change the numbers a little bit and say, does it make sense? Like if I change the number to 50%, it's easier for me to think in my head how to do it, right? Was that the case with you guys? And then once I get that, then I can say, oh, I understand the mechanics of this problem. All I got to do is change these numbers. So I changed the numbers and it worked out. All right, that's how I would approach a problem. Your teacher doesn't know everything off the top of his head. I don't memorize every solution I see. I'll just approach it and I'll just be like, I think this might be correct. Let's check to see. Got it? All right. Erasing. I want you guys to write this down, and then we're going to do something that is more lab kind of style, and it's actually going to be a lot of fun. We're going to be covering balancing equations, which I don't have my balancing equations paper on me. Give me a second. Somewhere on here.
I wish I could have so
I had a whole balancing equations worksheet that I was going to do with you guys. All right, I guess I can't find it. Let's take a look online. Balancing equations worksheet. I had it right here. I'm going to do a few of these for you. All right, cool. Let's do this one. N2, H2, NH3. All right. N2, H2, NH3. I'll be honest with you. So I asked Celeste. I said, Celeste, how did you learn how to balance this equation? And she said, or I asked Celeste. I said, Celeste, what is your technique for balancing this equation? And she, yeah, this girl right here. And she just said, I just do it. You know, you just kind of figure it out. And the problem is that's how I learned it too. And so when we're balancing equations, I'm sure that I'm going to give you guys some I mean, like, I almost feel like the best way to teach it to you is just to make you do a bunch of them and figure out some techniques. But I'll show you my tricks. And I told you that I wouldn't. I told you what I was going to do is make you do 20 problems or so, and then you'll figure out the tricks. But I'll show you mine. Because I think that, I mean, this is our last lesson, and we don't have a whole lot of time because there's a lot I want to cover today. Here's kind of what I do to balance an equation. All right? And this is actually interesting because it's very different from how Celeste does it. You kind of start off with the most complicated molecule that you're dealing with. In this case, what is it? The NH3. That's the most complicated looking one. So I put a 1 in front of it. Got it? And then what I'm going to do is this. This is, again, mind you, this is how I do it, and it's very different from how Celeste does it. I'll show you maybe how she does it, and then I'll show you how I do it as well, or vice versa. I'll show you my way first. There's 2 nitrogens here. Got it? I'm going to put a 1/2 coefficient in front of there. That will kill this 2 nitrogens down to 1 nitrogen on this left side. Does that make sense? And that matches the 1 nitrogen on this side. For this one's a little funky. There's 3 hydrogens over here. There's 2 over here. So I'm going to multiply this by this coefficient. I'll show you. 3/2. Mathematically speaking, that works because the half will turn that hydrogen into just 1 hydrogen, and I'm multiplying it by 3. So now there's 3 hydrogens on the left and 3 hydrogens on the right. Does that make sense? No magic there. Just, I mean, that's the way I look at it. Of course, leave it up to Mr. Daldy to do a way more mathematical way of balancing equations than, you know, the biologist who just kind of plays with the numbers. I don't know. This is just the techniques I didn't even learn this. I just made it up. I don't even know if it's right. I mean, I know it's going to be right, but I just don't even know if this is like the way most people teach it. There is no such thing as having a fraction as a coefficient in balancing equations. So let's clear fractions, because I hate fractions too. I'm going to multiply everything by 2. That makes this 1N2, right? Plus 3H2 yields 2NH3. That equation is balanced. Let's check it. How many nitrogens?
2.
2. How many nitrogens?
2.
2. How many hydrogens?
6.
6. How many hydrogens?
6.
Balanced equation. I use this fraction method. Oh, why are the fractions there? The fractions were there only as an intermediate step. It was like a step that I used because what I want to do is these things come in pairs, and so I kind of want to kill them down to be singles. Single nitrogen. There's only 1 on this side. And then this hydrogen, it's almost like I don't know how to make this 2 into a 3 if I put a number out in front. You know what I mean? I guess another way that people think about this is kind of like this game of like, I almost kind of think maybe cross multiply, or almost it almost feels to me like it's like still another thing that has to do with fractions. It's almost like the common denominator between 2 and 3. If you had something like 1/2 and 1/3, and you wanted to add those fractions, what would you have to do first? You have to make them common denominators, right? So you would have to multiply this one by 3/3, and this one by 2/2. You guys remember this from elementary school days? And then that would make this thing 6 and this thing 6. And then this would be 3/6 and 2/6. And then you add them or subtract them or whatever it is you're trying to do. So it's almost kind of like, maybe another way to think about this is, oh, if I want to make this thing equal to that thing, I would have to multiply this by 3 and this by 2. Because that makes this 6 and this 6. You know what I mean? And then it just so happens that our nitrogens end up balancing. Boom, I'm done with that balancing equation. I didn't need no fractions or anything. You know what I mean? I really hate to say this, but the best way to learn how to balance equations is just to do a lot of problems. So I should come up with a lot of problems for you to do. Although I decided not to do that, I'm going to make you do a quick lab, because today's class is not about balancing equations. It's about stoichiometry. So we're actually going to use this balanced equation to do something else with it. And it actually relates back to our s'mores lab that we did 2 weeks ago. And I've been trying desperately to get you to this point where you can understand why the hell I did that in the first place. Cool? All right, let's try another one. I'm just going to make up let's see, C8H18 plus O2. C8H18. C8H18 plus O2 gives me H2O plus CO2. Is that the right? H2O, C8H18, CO2, H2O. Yeah, all right, good. So there's my formula. I don't know what this is. I almost feel like this is something that has to do with like burning something. This almost looks like methane to me. You guys can look it up, what is C8H18, but it almost feels like this is something that's burning and it's producing carbon dioxide and water, vapor. I bet you that that's what this chemical process represents. But you know what? We don't even need to worry about what it represents. Let's just try balancing this equation. You guys ready? Do you guys want to see it the fraction method, or maybe just another method to try to do things? What do you want to see? Another one. All right, cool. Start off with the most complicated one. Put a 1 in front of it. Okay? I'm gonna tell you the approach I'm gonna take. Usually I start off with the most complicated one, and then I see how that changes this side, and then I kind of go back and forth. The last thing I usually end up dealing with is this O2. What am I going to have in front of the C in order to make the C's the same? What am I going to have in front of here?
8.
An 8. Good. What am I going to have in front of the H, H2O, in order to make the H's the same?
9.
A 9. Good. Tally up all of the oxygens on the right-hand side.
16.
Is it 16? Oh, it's 16 plus 9.
Yeah. So,
25. Okay. The problem is I don't know what number I can put here in order to make that 25. In order to make the oxygens 25. I almost feel like my tendency is to, I'll tell you what number I can put there. I know exactly. It's 25 over 2. You know, and then we're going back to the fraction method. But you guys didn't want that.
So then just
What I would do is I'd probably double this. Because that would make, I would have to double this and double this, but that would make 50 oxygens on that side. Then I know how to make this thing 50. I'll just multiply that by 25. So let's do that. 2C8H18 plus blank O2 gives me 18H2O plus 16CO2. There's 50 oxygens on that side. I'm going to put a 25 out in front. Done. Balanced equation. Essentially, you guys see what the fraction kind of did. If I were to clear the fractions, I would have gotten the exact same answer. I like the fraction method. It works for me. It doesn't work for some people. You just really got to play with this thing until you figure it out. We cool with that? I'll do one more for you. And I'm not choosing these in increasing or decreasing difficulty. I'm just choosing random which problems I think would be. I'm just choosing at random which problems look hard and whatnot. This one looks hard. Can you do me a favor? Can you read off number 18 to me? Over here? You gotta come over here. Oh, you can see it over there?
No.
Perfect. Read it off. HNO3
plus NaHCO. Oh, Na.
plus Na
And then big H, big
H
C, big O.
HCO.
Yeah, HCO. All big.
Okay.
3.
Gives me
Na.
sodium.
And then NO. Capital NO. 3.
This is nitrous oxide. So this is sodium nitroxide. All right. What else?
3.
Oh, NO3.
NO3.
Oh, this is sodium nitrate. All right.
Plus
Or
H2O.
nitrite. Plus H2O. Is that
Yeah.
it? Oh,
No,
plus
and
CO2.
then plus CO2.
Isn't there a 3 after the HCO?
HCO is a 3? Yeah, you're right. It's HCO3. Whew, that one looks like a pain in the butt to balance. I get a drink and Mr. Dalday has changed form. What are you talking? Oh, I became a pretty girl and yeah. I do that sometimes. Anyway, I don't know how to respond to that. That was weird. I'm sorry. That one looks like a pain. Nah, let's do it. I mean, let's not be wimps about this. You ready? I'm betting that the most complicated one looks like this one to me.
Yeah.
I'll put a 1 in front of that. And I'm betting, I have a feeling that the H2O and the CO2, that's going to be my last ones that I'm going to deal with. Just letting you know. So if I put a 1 in front of here, do I have to change the NAs? No. There's one NA, there's one NA. I'm happy about that. What about the H's? Is my H's already balanced? There's 2 H's over here. There's 2 H's over there. Oh, I'm feeling pretty good about this. What about the nitrogens? There's one here and there's one here. Dang, that's pretty cool. What about the oxygens? There's 6 here and 6 here. Is that correct?
5 there. Oh no, 6.
Like a boss, I'm done. It was already balanced to begin with. Seriously? I mean, let me just check. How many hydrogens? 2. 2. Nitrogens? 1. 1. Sodium? 1. 1. Oxygens? 6. 6, and 1 carbon each. Done. All I need is, actually, technically what you need, actually you don't even need this, you just write it like that. If it's a coefficient of 1, we don't even write it. Boy, that was a junk problem. It looked all hard and stuff. It was like the longest problem I saw in the paper. I was like, oh, this should be good. Done. You guys like it? Balancing equations, not so bad? All right, I'm gonna let you guys try it. Go on your computers, open up PHET. That's the lab I want you to try. PHET. We're gonna spend some time doing that. You know what? I have a feeling I'm not gonna get to my stoichiometry lesson, which really bums me out because I really want to get to how cool this stuff is, but I don't want to rush you guys through this stuff. I'm gonna warn you guys about this. I won't finish stoichiometry this. I won't finish this stoichiometry lesson this quarter. I want to finish off chapter 3. I don't think I'm going to get to it. We only got 20 minutes. I do want you guys to have a lot of time to play with balancing equations. So I'm probably going to touch a little bit on chapter 3 in like the first week of quarter 2. Just letting you know. Sound all right? My goal is to at least get through chapter 5, 6, and maybe 7 by the end of December. We've made it to chapter 3 this quarter. But I mean, we went pretty hard at it. We tried doing it. All right. Are you guys at PHET? Did you guys look it up?
Is this PHET?
Yeah, that's the one. It's like I've got a bunch of simulations. There's a simulation that I found that I really like. It's called Balancing Equations. Type that in the search bar. Do you not have your computer? Oh. You can work together in groups.
Balancing chemical equations?
Balancing chemical equations, yeah. All right. There should be an HTML5 version. Click on that. Apparently, he likes the new Mr. Dalday better than the old-looking one. Sorry, you got the old-looking one back. All right.
The one with like Superhero 5.
Is there a Superhero 5? What are you talking about?
Yeah.
I'll tell you what. I'm going to chat you guys the link that I found that I was like, this is a really good website. PHET. This is the one I'm looking for. Is
You did the introduction of the game.
both. And that was going to be my class. My class was going to basically be, I want you to try this. Go through all 3 levels. Play it with your classmates. Here, I'm spamming you guys the link. Click on that link and go there. For those of you who are in class, it looks like this. Are you guys there?
Yeah.
All right, try the introduction. Then try the game. It's a lot of fun. And that wasn't going to be the rest of my class. That was actually going to be the first half of my class, and then I was going to teach you guys stoichiometry. But I don't feel like there's enough time. I feel like I'm just going to be cramming stuff down your throat if I try that. So I think if you guys get to balancing equations, I'll be happy with that. And which means I'll probably have to adjust the homework because we haven't finished everything in chapter 3. I'm going to take a look at what the homework is and possibly take homework off of your plate for chapter 3. Sound cool? All right, so at this point in the class, I'm done with teaching. I'm just going to walk around the lab and see if you guys need help. But all we're doing in the lab, folks, is just this website. And it's actually a pretty cool website, which will give you guys a lot of practice with balancing equations.
What do I do once I'm done with this introduction?
Go on to the game.
Oh, never mind.
All right? We only got 20 more minutes, that's why. And I don't want to teach you stoichiometry in 20 minutes. All right, you guys can log off. You guys can go. We're done with class. I guess the next time I will be seeing you in a lecture form will be in middle of October. Yeah, I won't see you guys till like October. All right, cool. What about the final question? What are you talking about the final question? The final exam you're talking about? Yeah, I'm not going to have any lectures. Next week there is no lecture. I thought I covered the last one on today's homework. Wasn't it that percentage one that we did? Yeah, I thought that was the one. It came out to be like 65200 with an error margin of 1,000. So you could have put in 66,000 and you would be still have the same. You would get it correct. All right. Are you talking about the one that's due? Is there something due today? Is that what's going on? And there's a question on that one. I'll check to see what's due today. All right, here, look. I'll check to see what's due today. I didn't finish lecturing all of Chapter 3. There's still stoichiometry that I wanted to cover today, and I don't feel like I can cram that down your throats in 20 minutes. I feel like that would be very painful for you. So, because of that, I'm going to probably cover the last bit of Chapter 3 at the beginning of Quarter 2, which means I'll probably have to take some homework off of your plate because I gave you all of the homework for Chapter 3, which is unfair of me. Yeah, you're saying, well, only if you have to give us less homework. I'll take it, fine, I'll do it. Yeah, all right. I have to give you less homework. I'm so sorry. I'm sure that that's like the worst thing that just happened to you. All right. I'm going to log off. I'll talk to you guys later. I'm going to walk around and have fun playing this game. Okay, bye.